x2 minus x3. So w2 is also linear, that can be also expressed as linear combination of x1, x2, x3, and w3 is equal to 2x1 plus 2x2 plus x3, right? So this all the three coordinates in the right hand side of this definition of the transformation all are linear. So that's why this transformation is linear. That is one of the simple definition and one of the simple way to check that your transformation is linear or not, right? Or just this definition is actually for general definition, but if you want to check that your transformation is linear or not, for Euclidean linear transformation. Euclidean linear transformation means what? If your transformation T is from Rn to Rm. So here our transformation is Euclidean linear transformation. So in Euclidean transformation, you can easily check that your transformation is linear or not. But in general, if you want to check your transformation is linear or not, in that case you have to use this definition, T of alpha x plus beta y, that is equal to alpha into T of x plus beta into T of y. So or T of x plus T of x plus y, that is equal to T of x plus T of y, and T of alpha x, that is equal to alpha into T of x. So but in Euclidean transformation, it's quite easy to check that your transformation is linear or not. So just remind this definition. Okay. Next question, questions 5C, second part. Using the matrix associated with transformation, determine the new point after applying the transformation to the given point x is equal to 2 minus 6. Rotate it 30 in the counterclockwise direction. This question was asked in 2 marks. Here is the solution. X is equal to x1, x2 and w is equal to w1, w2. Both are vector of R2. The rotation of x through an angle theta in the counterclockwise direction. This is our standard matrix which we will use to solve this example. The origin is given by the operator A is equal to cos theta minus sin theta. This is 2 cross 2 matrix, cos theta minus sin theta, cos theta. So what is our angle? Angle is 30, right? So this matrix we have to multiply with this vector, this column vector 2 minus 6. So whatever we get, that is our answer. Okay. So we are given x is equal to 2 minus 6 and theta is equal to 30. So the transformation T from R2 to R2 defined by w is equal to ax gives w1 w2, that is equal to cos 30 minus sin 30 cos 30. So and into 2 minus 6. So put the value of cos 30 and sin 30 in this matrix. Cos 30 is root 3 by 2 and sin 30 is 1 by 2. So we put the value of cos 30 and sin 30, root 3 by 2 minus 1 by 2, this is 1 by 2, root 3 by 2, multiply with 2 minus 6. This is simple matrix multiplication. You should know that when we multiply any two matrices, the number of column in the first matrix and the number of row in the second matrix, it should be the same, right? In that case only we can multiply any two matrices. So here number of row in the first matrix, that is 2, and number of column in the first matrix, that is 2, and the number of row in the second matrix, that is also 2, right? So that's why we can multiply this two matrices, otherwise we cannot multiply. So this first row is multiplied with the first column, so that is root 3 by 2 into 2, so root 3 plus minus 1 by 2 into minus 6, that is 3, right? So 3 plus root 3 you will get, and when we multiply this second row with this column, first column, 1 by 2 into 2, so that is 1, and then plus root 3 by 2 into minus 6, so that is minus 3 root 3, so 1 minus 3 root 3, so 3 plus root 3 and 1 minus 3 root 3. So hence the new point is 3 plus root 3, 1 minus 3 root 3. So when we rotate this vector in the counterclockwise direction with the angle theta is equal to 30, our new point, our new vector, we will get 3 plus root 3 and 1 minus 3 root 3. So this is the answer. Okay. Next question, question 6a. This question 5 is completed now. Question 6a. Find the eigenvalues and eigenvectors of the matrix A is equal to 8. This is 3 cross 3 matrix. 8 minus 6 2, minus 6 7 minus 4, 2 minus 4 3. This question was asked in 4 marks. Here is the solution. The characteristic equation of the matrix A is given by for the find of characteristic equation there are two methods, right? One is that you all know that determinant of A minus lambda I, right? So in the main diagonal entries we have to add minus lambda and then solve this determinant, right? So that is our characteristic equation. To find the characteristic equation we use this definition. This is another method which I explained to here to find characteristic equation. Both are almost similar. You can use any one of the method. The first method is already I told you, and already we solve this. We use this first method to find characteristic equation in many examples, right? So let's see one another method to find the characteristic equation. Lambda cube, this matrix is in size of 3 cross 3, right? The first term is definitely lambda cube. Okay, then minus s1 lambda square plus s2 lambda minus s3 is equal to 0. Now what is the meaning of s1, s2 and s3? So s1, the meaning of s1 is trace of A. Trace of A means the addition of the main diagonal entries, right? That is our trace of A. Now what is the meaning of s2? Sum of the minors of the elements of the principal diagonal. So we have to find the minors of the all main diagonal entries. So we have to find the minors of 8, we have to find the minors of 7, and we have to find the minors of 3, right? This is our main diagonal entries. So we have to find the minor of 8, then 7 and then 3, and then add all the 3 minor, right? I hope that you know that how to find the minor of any element in a matrix. So if you want to find the minor of 8, we have to just remove the column and the row in which that element is, and whatever all the terms, that is find out the determinant of that all the terms, 7 minus 4 minus 4 3, right? So that is the minor of 8. So that is 21 minus 16, so you will get 5. So this 5 is minor of 8. Then similarly we can find the minor of 7, right? That is remove the column and the row. So whatever the left elements are 8, 2 and 2 minus 3, so that is 8 into 3, 24 minus 4, that is 20, plus 3 into plus minor of 3, that is 8, determinant of 8 minus 6 7, clear? So 8 into 7, that is 56 minus 36. So you will get again 20, and add all the minors of the main diagonal entries. So you will get 5 plus 20 plus 20, you will get 45. Okay, now sum of the minors of the elements of the principal diagonal, that is s2, which we find 45, and this is s1, trace of A, that is addition of the main diagonal entries, that is 8 plus 7 15 plus 3 18. So this is 18, and then s3 is the determinant of A, that is 8 into 21 minus 16 plus 6 into minus 18 plus 8 plus 2 into 24 minus 14. So 8 into 5 40 plus 6 into 10. So 6 into minus 10, so minus 60 and plus 20, right? So determinant is 0, you will get. So the correct, now put the value of S1, S2 and S3 in our main equations, in our these equations. So lambda cube, you will get lambda cube minus 18 lambda square plus 45 lambda, and this is 0. So lambda cube minus 18 lambda square plus 45 lambda, that is equal to 0. Lambda will be common, and after that lambda cube minus 18 lambda plus 45, and when we factorize this term, you will get lambda minus 3 into lambda minus 15, because 15 into 3, that is 45, minus 15 into minus 3, that is 45, and minus 15 minus 3, that is minus 18. So when we factorize this second degree polynomial, you will get lambda minus 3, lambda minus 15. So basically you will get 3 eigen values, 0, 3, 15, and this 3 eigen values corresponding to this 3 eigen values, you have to find eigen vector, right? So definitely you will get 3 eigen vectors, because you have distinct 3 eigen values. Okay, so let's try to find the eigen vector. The eigen vector x is equal to x1, x2, x3 corresponding to an eigenvalue lambda is given by the matrix equation A minus lambda I into x is equal to 0, right? So this is our matrix A, right? Minus lambda I is identity matrix, so you will get 8 minus lambda minus 6 2 minus 6 7 minus lambda minus 4 2 minus 4 3 minus lambda into x1, x2, x3, that is equal to 0 0 0. So 8 minus lambda into x1 minus 6 x2 plus 2 x3 is equal to 0, minus 6 x1 plus 7 minus lambda into x2 minus 4 x3 is equal to 0, 2 x1 minus 4 x2 plus 3 minus lambda into x3 is equal to 0. Now first of all we want to find the eigenvector corresponding to lambda is equal to 0. So when lambda is equal to 0, the equation 1 becomes 8x1 plus minus 6x2, put lambda is equal to 0 in this matrix, 8x1, okay, then minus 6x2 plus 2x3 is equal to 0, then minus 6x1 plus 7x2 minus 4x3, that is equal to 0, and then 2x1 minus 4x2 plus 3x3 is equal to 0. So solving, want to find the value of x1, x2, x3. So solving x1, x2, x3 from the first two equations, right? First two equations you will get 1 2 2. The value of x1, x2, x3 is 1 2 2. We are using the Cramer's rule here. X1 is equal to, you can see, to find the value of x1, solving first two equations, minus 6, the determinant of minus 6 to 7 minus 4. So you will get minus 6 into minus 4, that is 24, minus 2 into 7, so 14. So 24 minus 14, right, that is 10. Similarly here you will get 20, and again here you will get 20. So 10 20 20. So finally you will get the corresponding the value of x1, x2, x3, that is 1 2 2. Okay, so this gives the eigenvector x1 is equal to 1 2 2 corresponding to the eigenvalue lambda is equal to 0. Now when lambda is equal to 3, equations 1 become, put lambda is equal to 3 in this matrix equations. This is equation 1. Okay, so just mention it, this is our equation 1. Put lambda is equal to 3, so 5x1 minus 6x2 plus 2x3, you can see this is 5x1 minus 6x2 plus 2x3 is equal to 0, then minus 6x1 plus 4x2 minus 4x3 is equal to 0, and then 2x1 minus 4x2 is equal to 0. So from the last equation you will get x1 is equal to 2x2, right? The third equation, x1 is equal to 2x2, and the first equations gives okay, first equations gives x3 is equal to minus 2x2. x3 is equal to minus, because of x1 is equal to 2x2, so put the value of x1 is equal to 2x2 here. You will get 10x2, 10x2 minus 6x2, that is 4x2, right? So 2x3 is equal to minus 4x2, correct? So x3 is equal to minus 2x2. Now so combine these two equations, you will get, put x2 taking x2 is equal to 1, so you will get x3 is equal to minus 2 and x1 is equal to 2. So thus the eigenvector corresponding to lambda is equal to 3 is 2, 1, minus 2. Now when lambda is equal to 15, the equation 1 becomes 15. So 8 minus 15, that is minus 7x1 minus 6x2 plus 2x3 is equal to 0, right? You can say this is our equations. Then minus 6x1, 7 minus 15, so that is minus 8x2 minus 4x3 is equal to 0. So this is the second equation, minus 6x1 minus 8x2 minus 4x3 is equal to 0, and put lambda is equal to 15 in the third row. So 2 minus 2x1 minus 4x2 minus 12x3 is equal to 0. So 7x1 plus 6x2 minus 2x3 is equal to 0. Then 3x1 plus 4x2 plus 2x3 is equal to 0. x1 minus 2x2 minus 6x3 is equal to 0. Solving the first two equations, again similar method, x1 upon, you will get 12 plus 8, 20. This is x2 upon minus 6 minus 14 minus 20, and this is x3 upon 28 minus 8.